In this section 3.7, we're gonna do an application of using synthetic division, which is what we did, I believe, in like the 3.4 or 3.3 video. So the goal of this section, we have two things that we're gonna answer. The first one is how can we graph something like this? F of x is equal to 3x plus 1 over x minus 2. There's several techniques, but the technique we're gonna do from this section is we're gonna use transformations of the equation 1 over x. So if you remember before, when we did transformations, we have to take this, we have to find our parent function, and then find all the transformations that work up to this function. But just from looking at this, we can't really see like what's the parent function. Before we usually had 1x, now we have 2x's. So it's not really quite apparent what the parent function is for this one. But how we're able to kind of find that is by using a synthetic division. And so the technique to use synthetic division in this situation, we just want to pretend like, say if we're just doing this, 3x plus 1 divided by x minus 2. So another way of just writing that is, 3x plus 1 divided by x minus 2. So if you remember, now let's do synthetic division with just this problem. So if you remember, the thing on the end, the right-hand side of the division, that's the number that we put right here. So since we have an x minus a 2, we're going to put a positive 2 right here. And the thing on the left-hand side, in other words, the thing on the top of our fraction, those numbers went right here. So we start with the highest power. We only have a power of 1. So we need our x to the 1 column and then just a constant column. So the thing in front of the x is a 3, and the constant is just a 1. So we're just going to do synthetic division with this. The first step is always bring down the 3, this is the first number. Multiply those two, which we get 6. Add these, we get 7. And if you remember, the last thing always goes into a box because that's the remainder. And this will be apparent why we're doing this in a second. So first let's talk about, remember those equations like the q of x, the r of x, the d of x, and the p of x. These are all from that same section. So in this problem, let's start with the p of x. The p of x is always a thing on top of the fraction or on the left side of that division symbol, so the 3x plus 1. The d of x is always the right thing or the bottom thing, same thing, so x minus 2. This is the remainder, 7. And this was the quotient. And so if you remember, we always start with one thing less than the top. So this is an x to the 1 column. So down here, this needs to be an x to the 0 column. But just in general, when you say x to the 0, this is just a fancy way of saying a constant. So what that means is that q of x is only going to be 3. And so for these problems, that's how it's always going to be. Your q of x will just be this number. Your r of x is always just going to be that number. The bottom's the d of x, and the top is the p of x. And so the last thing we need is, so if you remember that one equation, p of x is equal to d of x, q of x, plus r of x. So if we divide both sides, let's divide everything by this d of x. Divide d of x, divide d of x, divide d of x. Okay, so this left-hand side is this p of x divided by d of x. Here these d's cancel, and we just have q of x plus, and here we have r of x over d of x. So now let's fill this in. So p of x is 3x plus 1. D of x is x minus 2 equals q of x, which is 3, r of x, which is 7, divided by d of x, which is x minus 2. So you see what we just did? We said a second ago when we want to graph this problem, our problem was we couldn't find the parent function because there's 2 x's. And our technique to find the parent function was always just get rid of numbers except for variables and exponents. But that was only the case when we had 1x. But now, using this whole division technique, we were able to see this is our original problem. Here's f of x. We can rewrite f of x as 3 plus this. So now we only have 1x. So let's do this on a clean page now. So you have all this written down. We did this division stuff, and we got to this point now. Using this equation, we see that our original problem can be rewritten like this. So let's write down this top of this page. So our original problem was this. We wanted to graph 3x plus 1 over x minus 2. And then we used that whole synthetic division technique, and we saw that we can rewrite this as 3 plus 7 over x minus 2. And so the question is still, now we need to graph this. But this one we are able to graph using the transformations. So the parent function for this one is going to be 1 over x. Our first transformation, this minus 2, so it's 1 over x minus 2. Our second transformation is putting the 7 here, so we have 7 over x minus 2. And our third transformation is adding this 3. So 7 over x minus 2. So we aren't able to do this parent function stuff with this one because we couldn't figure out what's the parent function just from first looking at it. But after using that synthetic division technique, we can rewrite it like this and see that our parent function is 1 over x, and then we can add these transformations to it to increase to this function, which is the same thing. So now let's graph these 4 things separately. Let's start with 1 over x. And so this is just something that needs to be memorized. 1 over x looks like this. So we have 2 things going on here, or I guess just one thing in particular. Both of these graphs, this one gets really close to the y-axis but never crosses it. This one gets really close to the x-axis, never crosses it. And same with this. This one gets close to the y-axis, never crosses it. This part right here gets close to this axis but never crosses it. So here's 1 over x. Let's put just an xy table, just find a couple of points. If we plug in 1, so remember this is 1 over x. We get 1 divided by 1, which is just 1. Let's just do 2 points. Plug in minus 1, 1 over minus 1, that's minus 1. So you have these 2 points. Here's a point right here, 1 comma 1. Here's a point right here, minus 1 comma minus 1. And then here we just have like, the general shape of it. Okay, now let's do this one, 1 over x minus 2. So remember, this minus 2 directly to the x, that means we're going to move everything to the right 2 units. So this point gets moved over to the right 2 units. So now it's going to be a 3, 1. This one gets moved over to the right 2 units. So now it's going to be a 1 minus 1. Okay? But remember, we're moving everything to the right. So whereas before we got really close to this line, as the graph went up over here and down over here, so that needs to move over to the right 2 units. So now it's going to be over here at 2. We're going to have this line. And we're going to be getting close to it this way. Okay, and we're still only getting close to the x-axis. So now we're getting close over here. And you may be asking, okay, why didn't this line change? So we can easily see, since everything's moving to the right, as we're getting close to this line, if we move everything to the right, well, this line that we're getting close to has to also move over to the right. But yeah, again, like I said, you may be thinking, what about this line down here? Why isn't this one changing? Why are we still getting only close to this axis as we go on? When you think about it, this is the line right here. This is the line that we're getting close to. If we just move it over to the right, nothing changes. We're still getting close to that same line. Like that line doesn't move up and down if we're only moving to the left and to the right. And so for that reason, we're still only getting close to the x-axis. All right, so let's move on to the next graph. The 7. So all we're doing here is we're multiplying this entire problem by a 7, so on the outside of the x, meaning we take all of our y values and multiply it by 7. Here's a y value of 1, so multiply by 7, it turns into 7, so now we have 3, 7. Here's a y value of minus 1, now it's going to be down here at 1 minus 7. Okay, so all the y values on this line are 2. So you think about it, so this is just a line going, sorry. The y values are changing. The x values are always 2. So if we multiply all the y values by 7, the x value still stays the same at 2. So basically this line isn't going to move if we multiply all the y values by 7. So we're still going to have that line at 2. And if you think about this line, all the one we're getting close to here, all the y values are 0. So if we multiply it by 7, 0 times 7 is still 0. So this line also is not going to change. So we're still going to have the similar shape, this. All right, now let's move on to the last graph, this plus 3. Okay, plus 3 means we add 3 to all the y values. All right, so here's a y value 7, add 3. Now it's going to be a 310. Here's a y value of -7, add 3, now it's going to be -4. Okay, we're adding 3 to all the y values on this one. The x values aren't going to change. This line's not going to move to the left or to the right, so this line's going to stay the same. Here's our line at 2. We still have that vertical line going through that one. But think about it, now this line's going to change. We're multiplying adding all of our y values to 3. So all the y values on this line are 0, but when we add 3, it just moves up 3 units. So now that line's going to be going through this point right here. We're going to have a line going through 3. So then our last graph is going to look like this. Oh, sorry. No, we're okay. Okay, and so this will be the final graph for this problem. All right, so the last thing from this section is going to be, we'll talk about two definitions. Let's do it with a picture. So say if we have a graph that, let's draw a dotted line right here. So sort of like the similar graph that we just did in the last problem. A dotted line right here. And then how about something like this? Okay, so these two lines have certain names. So this line right here, this dotted line, is called a vertical asymptote. And then this line right here, this dotted line, is a horizontal asymptote. It basically is just a fancy way of saying this is a horizontal line and the graph gets really, really close to it as we go on in both directions, like over here and over here. And a vertical asymptote is just, a line that the graph gets really close to, like we are right here, but it doesn't touch it. And so say if we're just given an equation, we'll do this generally. Say if we have something like f of x divided by g of x. So, and these are going to be polynomials, meaning something like this. So it's going to be something of this form. Say, for example, let's just write it out completely. We'll have, say, an x to the n plus a1x plus a naught divided by bn x to the n, or let's make this an m, plus b1x plus b naught. All right, so this is the general form. A little example of something, a possibility for this one, maybe something like 7x to the 4 plus 3x squared plus 1 divided by 11x to the 15 minus 16x squared plus x. So this is the general form, this is just an example. So something, that kind of looks like that. Basically just numbers and x's with powers. So let's start. The vertical asymptote is the easiest one to find. So to find the vertical asymptote, all you gotta do is set, let's use these over here, f of x and g of x. So set g of x equal to 0, solve for x. And these numbers you find, those are gonna be the vertical asymptotes. Now the horizontal asymptote, we're gonna have some cases. So what we're gonna say is, suppose the power of x on the top is bigger than the power of x on the bottom. So that's not the case in this situation. The power of x on the bottom is 15, the highest power, and the highest power on top is only 4. So in this situation, the power on the bottom is bigger than the power on the top. But for this first case, let's suppose, so let's call it, say, the power of f of x being the thing on the top, is bigger than g of x. Again, g of x being the thing on the bottom. So this is going to imply that we have no asymptotes, or no horizontal asymptotes. Okay, the second situation, let's put it over here. We have the power of f of x is equal to the power of g of x. So in that situation, Let's just write everything out in numbers and we'll do examples in a second, or with letters. This means that the horizontal asymptote is going to be y equals an over bn. The an and the bn being these two numbers. So remember here we're saying the power of f of x and the power of g of x are the same. So this power right here, n, would be the same thing as this one. So these two would be the same letter if they had the same power. And so this is going to be the horizontal asymptote if the powers on the top and the bottom are the same. Is this going to be the number in front of the top exponent divided by the number on the bottom of the bottom exponent? So we'll do examples in a second. These are just sort of like the general forms. And then our third one is suppose the power of f of x is less than g of x. And then in this situation, we have y is equal to 0 is going to be the asymptote. So let's do 3 concrete examples with each of these 3 little definitions. And also with the vertical asymptote. Okay, so for example number 1, let's suppose we have this function right here. Let's call it, we don't need to call it anything. How about like x to the 10 plus x cubed all over x to the 9. Oh no, let's make it easier on the bottom. Sorry. Let's do x to the 10 plus x to the 3 all over x squared plus 2x plus 1. So first let's talk about the vertical asymptotes, since those are the easiest. The vertical asymptote, all we have to do is just set the bottom equal to 0, in this situation this, and then solve for x. Okay, so all we have to do is solve this equation. If we factor this is going to factor into x plus 1. Since 1 times 1 is 1, 1 plus 1 is 2, so that equals 0. And so then we're going to get x equals minus 1. So our vertical asymptote is this line right here, x equals minus 1. And remember, this actually is a line. X equals, minus 1. X equals minus 1 just means here's minus 1. It's just a vertical line going through that. This right here is the line x equals minus 1. All right, now let's talk about the horizontal. So if you see here, the power, what's the power on the top? The power on the top is 10. And so let's say that power of the top is 10. The power on the bottom is 2. So in this situation, we look on the previous page, since the power on the top is bigger than the power on the bottom, it says that we have no horizontal asymptote. Okay, now let's do another example. Let's do about, let's make this 13. Okay, we have this equation. Let's start with let's only do the horizontal asymptote for this one. The vertical one, well, this one it's not going to be possible. We'd have to set the bottom equal to 0, but that's just no way without a computer to solve this one. Anyway, so let's just do the horizontal asymptote. Okay, so that all we have to care about is the power on the top and the power of the bottom. So power on the top, the biggest one's a 13. Power on the bottom, also equals 13. So in the previous page, that means that the horizontal asymptote is going to be y equals, and we take the number in front of this power on the top divided by the number in front of this power on the bottom. So the number in front of the 13 on the top is a 2, so we're going to have 2. And then the number divided by the power on the bottom is 13, which is a 16. So that just equals 1 over 8. So that's going to be our horizontal asymptote. All right, let's just do one last quick example of the third case that can happen. And we can fit it in right here. So say if we have something like 16x squared minus 1 divided by x to the 100 plus x. So here the power on the top, so power top is equal to 2. And here the power of the bottom equal to 100. And in this case, whenever the power on the top, here 2, is less than the power on the bottom, here 100, this is going to tell us that y is equal to 0. That's going to be our horizontal asymptote. So this is the horizontal asymptote. And again, to find the vertical asymptote, we would have set the bottom equal to 0, but that's kind of hard to do with a 100th power, so you need like a computer for that. So just for the horizontal asymptote though, it's going to be 0, and that's because the power on the top, which is 2, is smaller than the power on the bottom, which is 100.